Welcome back to another episode of Messari's Unqualified Opinions. Really excited to have, once again, a technical conversation. I'm probably going to be out of my depths covering with the co-founder and CEO of BloXroute, Uri Larman. So we're going to cover quite a bit about layer 0, block propagation.
Correct.
And just general scalability and security challenges that BloXroute is working to help fix. A lot of interesting things that we can dive into, but I want to make sure that we keep this at a reasonable, maybe 201 level at the highest.
I think anybody who knows anything should be able to understand what we're talking about. So this is going to be very easy.
Certainly the 101. I'm going to try to get to 201 and IC3 and kind of what led you to the industry in the first place, I suppose, but then more specifically to working on this block propagation problem.
Sure. So I recently graduated my PhD at Northwestern University. Mm-hmm. So I myself am from Northwestern, and my co-founder is Professor Alex Kuzmanovic at Northwestern. He was my advisor and net neutrality expert. And we work with Goon, Professor Emin Gun-Sirer, the crypto expert at Cornell, and Sumya Basu, the creator of the Falcon network, and we came together. So I found, I think like most crypto people, I stumbled into this space like one day through in my case, my research, and figured out, oh, there are very interesting things that we could do there. Mm-hmm. And for me as a networking person, it immediately something's really popped out that I think others might have missed. So once we figured that there are very interesting things we can do in the blockchain space, I connected with Goon, I connected with Sumya, and then we realized we have this solution that solved the biggest problem in blockchain, and 2 years later, here we are today.
Well, let's get a little bit more specific about what that problem is. And so what year did you start working on this full time?
2017, I think.
The research or the company itself?
The company, so company-wise, there was a company, but then it was an Illinois company, and we had to change it for investor, these kind of stuff. Mm-hmm. Started working on it full-time, I think, beginning of 2017. Got interested in crypto, obviously, a bit in research, like a year or two ahead of that. Mm-hmm. And the problem that we're talking about is obviously, if it wasn't clear up until now, it's a scalability problem. Mm-hmm. So the only thing I think that prevents from blockchains and crypto from really getting traction and do all the cool things everybody are really excited on doing, they all really depend on having scalability to do that. You need, if you want Bitcoin to compete with credit card companies are processing 5,000 transactions per second on average today, and they peak at hundreds of thousands of transactions per second. So just for the money, and even without micropayments, you need orders of magnitude more than the 3 transactions per second Bitcoin is doing. If you want to do the Ethereum and smart contracts and all kind of that, we're talking about very high volume of transactions per second, which today blockchains simply can't do. And I think the unique thing that we do is to identify what is it, where is the scalability, why can't we do it? And if you take the time to identify the problem correctly, you're very likely to find a solution for it, because very few things are impossible.
Now, your approach is very, very different from other approaches to solving scalability, and you call it layer 0, right? So trying to tackle the block propagation challenge, which is essentially how the network communicates peer-to-peer before the rewards are mined and additional blocks are added to different ledgers.
So even before that, let's simplify it. We said let's keep it simple. So let's make it as simple so anybody, like the audience, it's completely clear to anybody out there. Before what is the solution, let's say what is the problem. Mm-hmm. If you're looking at a blockchain, and it doesn't matter if it's a proof of work where some miner tries many hashes until it can produce a new block, or it's a proof of stake where somebody is randomly selected or a group are voting or something, they all end up having exactly the same problem. It turns out that if you take a blockchain, let's say a POS system, usually I give Bitcoin as an example, this time I'll try a different example. There is a blockchain that's doing, let's say, an Ethereum kind of thing, 10 transactions per second. Mm-hmm. If you want to scale that, if you want to do more transactions per second, you can do one of two things. You can add larger blocks to the system. So in Ethereum, it's gas limit, but it's easier to talk about actual size in megabytes. So if you'll do 10 times larger blocks, you'll have 10 times more transactions in the blockchain. Or you can reduce the time between blocks, but it doesn't matter which approach you take, you end up having the same problem. It turns out that if you take a blockchain and increase the block size by a factor of 10, then if I'm producing a new block and I have to send it to everybody out there, it's going to take me 10 times longer to send it to my peer, right? 10 megabytes versus 1 megabyte. And the time it takes for the block to reach everyone increases by the same factor, by a factor of 10. So the time it takes for a block to reach everyone takes 10 times longer. And this is a problem. And why is that a problem? Think about, again, in a POS system, you can't, if somebody is randomly selected to mine the next block, he can't mine the next block until he got this block, right? He can't do that. So if the time it takes 10 times longer, then even though you made 10 times larger blocks, well, it took him 10 times longer to hear of the blocks. You remain with the same throughput, right? You increase the block, but now you also increase the time between blocks.
Now, it makes perfect sense. Help explain why you're starting at that level versus layer 2, which is where most other scalability innovations are happening today. And I think the general thesis historically has been Bitcoin, Ethereum, some of these other blockchains do not actually need to be super scalable for that exact reason, that you don't want the block size increasing such that it congests the network and it slows down the peer-to-peer communications. So instead, should we be using these blockchains as a settlement layer versus thinking about them at the lowest layer where all transactions should be getting thrown into the system and worried about throughput at that level? You're obviously thinking about layer 1 and layer 0 scalability versus layer 2. What's important about that?
So let's think, why are we doing settlements and layer 2? Right? The question is people build layer 2 solutions because they need scalability and they don't have it. So if you don't have it, you try to build a solution for that, which makes sense. But you should probably better understand what bottleneck, what is really the problem that prevents you, because you'll hear all sorts of explanations. Most of them a lot of hand waving. So people would tell you, oh, nodes, you want the simple, whoever runs a node at home, he needs to process a lot of transactions. So there's a problem of CPU there. But it turns out that your home computer today, if you have a mid-grade computer, it can process something like 3,500 transactions per today, right now. And that's not even a strong computer, just your average computer. So that's definitely not the problem, right? That's not the limiting factor. You can do, you're stuck at 3 or at 10 today. So you can definitely do more than that. Then people will tell you, oh, it's a bandwidth problem. Well, if you have the regular 60 megabit per second link, that's probably half of what you have at home. That's enough for 15,000 transactions per second. Okay, so bandwidth isn't the problem either. Then you get people who tell you, no, it's a storage problem. You can't store the entire blockchain if it's very, very big. But then comes a question, if you're running a node, do you really need to store everything from Genesis or let's say last 10, 50, 100, 500 blocks? So you don't really need to contain all the history. Probably. You might if you want for a specific service or something like that. But they're again, there is a problem, the scalability problem, but nobody says what is the problem. So I'm going to state, before talking about the solution for it, I'm going to say what the problem is. The problem is the time it takes for a block to reach the entire network. So people talk and say, people call this the block propagation time, right? And people would, specifically in Bitcoin Core, BTC, people will say there is no block propagation time. Blocks propagate to everybody very, very, very fast. But the reason that that's happening is because some people created relay networks and there's some problem. You have to trust the relay networks to propagate for you. If you look at historical data, blocks would take 30 seconds, 50 seconds to reach everybody. This is the limiting factor. It's not about storage, it's not about CPU, it's not about bandwidth per se. It's about how long does it take for a block to reach everybody. Because you can't just arbitrarily make larger blocks, because if you do, then depending on your specific of your blockchain, one of two things would happen. Either, as we said, the block will take, you'll do 100 times larger blocks, they will take 100 times longer to reach everyone, and you remain with the same throughput. Or if you're thinking something like Bitcoin, or a very simple like proof of work blockchain, then you mine a block, you start sending it, but it takes so long, like more than the 10 minutes interval between blocks. And then somebody else, while waiting for your block, he will also mine a block. And he will create a fork in the blockchain, not intentionally, he just didn't hear about your block. So the blockchain will have forks, and then forks of forks, and forks that they will just like, rather than converging back to a single blockchain. So that kind of makes sense.
Of course, and the solution to this initially was, in Bitcoin, the creation of relay networks. My understanding is correctly, relay networks were built to ensure that smaller mining pools were not getting exploited by larger mining pools, who would take advantage of this block propagation problem to selfish mine, essentially discover a block, reduce their own propagation time or how they transmitted that information, and basically give them a head start on the next block. And then as soon as a competitive block was mined, they'd mine that one and then continue working.
So you're correct. Let's keep it super simple. So for the people who don't know what a relay network is, a relay network is just somebody who deployed a network of servers all around the world, and they're optimized to propagate blocks fast. So think using AWS or Google Cloud or something like that. You send it to them, they broadcast it to everybody else. So such a relay network, the first one was deployed by Bitcoin core developer Matt Corello. My co-founders, Professor Goon Seer and Sumya Basu, created the Falcon network, which is also a relay network.
They wrote the selfish mining paper.
So yes, but their goal, neither of them actually, like, they weren't even considering scalability. So they said, oh, exactly for the reason that you said, we want blocks to propagate like fast because it helps to keep the mining more fair. And that was their goal. Nobody was talking about scalability. And this solution, a simple relay network, is not really a good solution for this problem. So it's a naive solution. It's like, oh, that kind of solved the problem. Let's use somebody who's specializing exactly in propagating blocks. But then you change the security model. If everybody have to rely on a relay network to propagate the blocks, now the relay operator controls what goes on the blockchain, what doesn't go on the blockchain. He likes you a lot. He'll take your block, send it to everybody else. But the other guy, he's like, oh, you'll have to pay me $5,000 a month for me to propagate your blocks, or reject them completely.
Are the current relay operators in Bitcoin the mining pools, typically? Or how is that market segmented?
So there are relay networks, so there are several of them that miners kind of like use to internally propagate blocks really fast. But I want to emphasize that in Bitcoin, BTC, Bitcoin Core, this is not a concern. There isn't a concern about somebody rejecting blocks and censoring, because in BTC, blocks are the size of blocks is 1 megabyte. So worst case scenario, if you are the relay operator and you decide to reject somebody, it can just propagate peer-to-peer. It will reach everybody. It's not that big that it's a problem. But if you want to do scaling, okay, and this is why like the Falcon and Fiber, they weren't looking into it. They weren't trying to scale. So it wasn't an issue that the fact that you have to trust them, because you can always propagate without them. But if you want to use a relay network in order to scale, to propagate blocks fast, so you could do gigabyte blocks, then you have to make sure that this is not a single point of failure. You have to make sure that they're not the one controlling which transaction go on the blockchain and which transaction don't go on the blockchain, because they can do really nasty things, right? They could say, I'm banning all blocks that touch specific wallets, or they can be like forced by whether it's like law enforcement or whoever, or they have their own economic incentive. They can reject somebody, like let's say Satoshi Nakamoto's supposed like 1 million Bitcoins, reject any block that has a transaction that touches them. And if the relay network rejects such a block, it can't just propagate like through the peer-to-peer. It's just too slow. It will reach like 5 peers, and then somebody else would also mine a block that it will propagate and will orphan that out. Does that make sense?
I think so, and so I think we have enough proper context for how this architecture works, why it's important, and what the real predecessors were to BloXroute in relay networks. to talk a little bit more about your specific solution, and that's you call it the blockchain delivery network, which is a play or spin-off of the internet's content delivery network.
Right.
So talk a little bit about your positioning. Do you see many content delivery networks emerging over time? Should most traffic route through a single BDN like yours, or is it per blockchain?
So the shortest answer is I think there should be one with backups. But before that, let's say, so the problem that we're solving is propagating a lot of data to a lot of people fast. This is what we're doing.
Specifically on non-Bitcoin blockchains?
So for current Bitcoin, whether it's BTC and Bitcoin Cash and Ethereum mainnet, they're all currently already connected to BloXroute. But for any blockchain out there, whether it's proof of work or proof of stake or permissioned or permissionless, they all suffer from the same problem. They have to send a lot of data to a lot of people fast so the next block could be mined. This is a problem, and it's a stupid problem to have in 2019 because, as you said, Akamai, the first CDN, the first content distribution network, solved this in like 96. Okay, we know networking experts, or generally speaking, networking industry, know how to send a lot of data to a lot of people fast. We're now doing this video, right? We're sending, I don't know, 4K video to 100,000 people all around the world. And it goes
I hope it's 100,000.
It should.
If Zach's doing his job, it'll be 100,000.
So we really know, like think of YouTube, right? Sending terabytes of data to hundreds of millions of people all around the world. We know how to send data. How do we take this and bring it to the world of blockchains? This is what we do. And we really have two pieces of our architecture, right? We have performance. We have to be able to do thousands of transactions per second out of the gate. And we have to make sure that we are provably neutral, that we can't censor, that we can't discriminate. Because if we can't do that, then nobody should use us, right? We shouldn't be the single point of failure. So what we do at BloXroute is similar to a relay network. It's a blockchain distribution network. As you said, it's taking the idea of a CDN and bringing it to blockchain. And we have a relay, a network of servers deployed all around the world, which is optimized to send blocks faster. And the way blockchains use BloXroute is, well, blockchains use BloXroute, it's a lot of beacons. We do this in a way that blockchains don't need to change their protocol, they don't need to change their implementation, they don't need to reach a consensus to start using BloXroute. It should be like if a miner decides, should he use AT&T or Comcast? It's deciding who is his networking provider, right? It doesn't ask everybody, oh, who should we use, right? So we aim to provide the same thing. And the way it works is that if you're a Bitcoin miner, we give you a small piece of open source code. That's your gateway. Take this code, run it on the same machine that you run your miner. And if your miner is connected this peer to this peer and this peer, add this gateway just like any other peer, only it's a friendly neighbor peer. It's a peer that sits on the same machine. And if you mine a new block and you want to send it to everybody, send it to all your peers, including the gateway. Only the gateway will send it to everybody else 1,000 times faster. And he will tell you of blocks from the outside 1,000 times faster.
How does that work though? Because your limit is the speed of light.
True.
So you're, no matter how distributed the system is, if a block originates from one IP, it still has to make all of these different hops. You can't just alter the laws of physics.
It's true. It will never be under something like 250, 300 milliseconds to reach an entire world. The question is, that's for a 1 megabyte block. Can we do a gigabyte block that takes approximately the same time? Or can we do, so this is the question, and each blockchain can decide. We just provide the infrastructure. Each block, do we want to do 100 times larger blocks at 10 times shorter time intervals, so 100 megabyte blocks every minute, or 1,000 times larger blocks every 10 minutes, or these are two parameters that each blockchain can decide for itself how they want to play with it. Our job, so you're correct, you can't minimize the time indefinitely, you have the speed of light, but in this short period of time, in the hundreds of milliseconds, we can propagate 1,000 times more transactions, okay, so gigabyte blocks at the speed of a 1 megabyte block. So this is our performance piece. And I'm putting aside our neutrality for a second because it's easier to talk of each of them individually.
Yep, we'll get to that.
So how do we do that, right? Like we said, 1000x is like this magic number that seems to be completely made up. Like how BloXroute allows to do 1,000 times more transaction per second using two very elegant, very powerful, but at the end of the day, very simple techniques, okay? Transactions in a blockchain are generally known in advance, right? In 99.99% of the cases, a transaction propagates, it reaches everybody, and then somebody mines a new block and it has to be propagated. But everybody had already seen that transaction, right? So when propagating a block, you don't really need to propagate the transaction itself. So what we do internal to BloXroute, okay, the nodes are unaware of it, it's completely internal to what we do. We map each transaction, and transactions go between like the average Bitcoin transaction, something like 500 bytes, and we map it to a 4-byte ID. So we really create saying like, oh, this is transaction 5, this is 17, this is 37, completely arbitrary. We decided by ourselves, it's completely, it's not hashing of transaction, it's nothing like that. We just create a mapping, which is very easy to do for us internally, right? And these gateways that everybody are using, we push to everybody, so each one of them, they all have the same hash table, they have the same mapping. So they know this transaction is 1, this is 2, this is 3, etc., etc. When some miner mines a new block and want to send it to BloXroute, it gives it to the gateway receives it, and what is a block? A block is a tiny header and a long list of transactions. So it replaces each 500 byte transaction with a 4-byte ID, compacting the block by a factor of 100. Send that to BloXroute, the BDN, okay, our network of servers, which broadcasts it to everybody else. And if my gateway on the other side of the world, when it receives it, it reconstructs the original block. So it taking the ID and mapping it back to the original transaction, reconstructing the original block, and give it to the node that my gateway is serving. So on the wire, in the money time, where timing is super critical, we propagate pieces of data which are 100 times smaller. So we can propagate 100 megabyte blocks at the speed of a 1 megabyte block, because we don't really send the entire blocks. We just send pointers or IDs, which can be reconstructed. So this allows us to propagate 100 megabyte block at the speed of a 1 megabyte block.
How many transactions can fit in a 4-byte ID?
So 4-byte ID, let's do it. 4-byte is 4-byte is,
trying to do the quick
is 32 bits. Okay, so that's 2 to the power of 30. So that's a billion.
Plenty.
Okay, so 4 billion if you want to be exact. And if you do that, so we could actually do, if we want to squeeze it, we thought of doing 3 bytes. That would actually be suffice. But then you'll have to kind of like make extra techniques.
Could be collisions.
And precisely, you have to play with the space, and kind of like it's harder. So. Generally, building an architecture like simpler is better. We rather do 4 bytes, although we can do slightly less, and then everything.
It's still 4 versus 50,
so it's 2 to the power of 32. So it's kind of and it's sufficient to do actually hundreds of thousands of transactions per second. So this is technique number 1 that we do. Fairly simple, right? That's like anybody should be able to, I think, to understand that we just send smaller pieces of data, and that allows us to do 100x. We're still not at 1000x, right? The second thing that we do is that when your gateway receives a block, compact it by a factor of 100, and send it to BloXroute, our servers don't wait until they receive the entire block and only then send it in a store and forward model. We do something called cut-through routing or streaming. We receive it and we start sending it. So by the time the last packet arrives from your gateway, we already broadcasted everything else, and only that packet has to be sent. This gives an additional between 10x and 100x improvement. And between these two techniques, we do more than a factor of 1,000 faster. So we can do gigabyte blocks, which would propagate at the speed that the 1 megabyte block would require. And this is how we get this magical 1000x. We can actually do way better, a lot better with more sophisticated techniques. Nobody needs that today, so we decided to start with the simple, and okay, we'll do the more sophisticated techniques when we'll need them, but we can do another between 10 and 100x, like in addition to that.
So So let's talk about the second component then, which is provable neutrality, because this makes sense, right? And in much the same way that a centralized database is
precisely
more dynamic,
right?
Because you're able to do things with this centralized network.
Right. I can do that mapping between transaction and IDs, and I don't have to worry. Oh, what if somebody creates another transaction and gives the same ID? Right.
Yep.
If this was a peer-to-peer system, this is why a peer-to-peer system can't just can somebody just copy the technology? You can't put it as part of the protocol, because if somebody is misbehaving, it will break everything. It can spam, it can do a bunch of stuff.
So it inserts you in a very important structural position, which is where the provable neutrality comes in. So how have you tackled that problem? Why do people trust you by default?
So let's talk about what must we make sure that BloXroute can't do. It shouldn't be able to censor, and it shouldn't be able to discriminate based on where a block is coming from, where is it going to, what it contains, and it should also not be, even if it's completely fair and neutral, it shouldn't be a single point of failure. What happens if BloXroute goes down, right? So we have to make sure it's not a single point of failure. This is what we must achieve. But even reaching this point, like, okay, so now we're talking practical solutions, right? It's kind of like, okay, we can do scaling, we can do thousands of transactions per second. How we make sure we don't break the security model? So the way BloXroute works is, again, similar to the performance techniques, very simple things. They're just elegant and work. So to prevent BloXroute from discriminating based on the content of the block, okay, what's inside it, when your Magic Gateway receives a block, it compacts it, and then before sending it to BloXroute, it encrypts it. So you send an encrypted block to BloXroute. So BloXroute will blindly send that block to everybody else. We don't know what's inside it. And your gateway will only send out the key after your gateway hears from his peers, the other Magic gateways, that they have received the encrypted block. So gateways create a peer-to-peer network of their own. And if you send an encrypted block, if your gateway receives it, oh, I got this, and they only send you the hash of the block, right? They don't send you the entire thing that they received. And BloXroute doesn't know who you're connected to. You hide that. So you only reveal the content of the block after it reached everybody. So we can't, at this point, we can't do anything about it, right? So let me rephrase that, because I think it wasn't entirely clear. The content of the block is only revealed after BloXroute has sent it to everyone. So we can't discriminate based on the content because we don't know it. And once we know it, it's already too late.
Does that require an opt-in on the receiver's part too? So a sender of one of these transactions would encrypt, send it through BloXroute, but the receiver on the other end has to decrypt, correct?
So let's split between transaction and blocks here. If you make a transaction, you just make a regular transaction. You don't know that BloXroute exists. You don't care that BloXroute exists. You make a transaction, everything remained as is, okay? That's a user. You went to Starbucks and bought coffee with Bitcoin or whatnot. If you're a node and you receive the block, then you run that gateway. Your node also doesn't care, right? He just thinks that the gateway is another peer. He doesn't know of this entire behavior. So this entire behavior is between the gateways. And gateways, the way they act is when somebody gets a block, it encrypts it, send it to everybody else, and when he hears from the other gateways, each gateway tells, oh, I got this, oh, I got that. So they tell all their peers. And when your gateway hears that his block was already sent to everybody else, only then does it send the encryption key. Did that answer the question, or did that cite?
Yes, I think the key missing piece for me is the incentives for the gateways.
So gateways. So we wrote the gateway. It's open source, so anybody can audit it, or it will be open source once we publish it. Okay, so I'm going to answer that, but I'm putting all this aside for a second. Why would anybody? What's the incentive to use BloXroute? Okay, so we're going to have to do a side shift in the conversation. There is a long-term value and there is a short-term value to use BloXroute. The long-term value is that BloXroute aims to reach this win-win-win scenario where everybody is extremely happy. So if BloXroute allows for 1,000 times more transactions per second, users can pay 10 times lower fees than they're paying right now, while miners will make 100 times more fees in total, right? Each fee is 10 times smaller, but they make 1,000 times more transactions. So users are happy. That's the first win. They pay smaller fees, and miners are happy because they make 100 times more fees. So that's their long-term value in using BloXroute.
And is it because the miners, instead of rank ordering transactions based on fees directly, are now relying on you to process those fees?
No, so we actually don't do any of that. Miners already today, they can do whatever they want, right? They do over the counter, they have deals with people like with exchanges to include their transaction fast, all these kinds of stuff. They can always do whatever they want. Our value proposition is to say 1,000 times more transaction per second allow value capturing both by users by paying lower fees, and miners they just make more transaction per second, right? So they make 1,000 times more transaction per second. However they decide to include them, assuming each fee is 10 times smaller, they make 100 times more fees.
Well, this also assumes that whatever blockchain you're working with and powering increases the block size.
So
because you can't have 1,000 times.
You're right. So this assumes like, okay, that
there's
the
an
protocol,
upper bound for Bitcoin, for example.
So right. So like in Ethereum, miners can increase the gas limit by themselves by up to 10% of their like whatever the last X blocks were, right? So they can decide from themselves. A lot of protocols don't have this limit, but we keep sides like talking about different aspects, but our idea, we don't do our own blockchain, right? We're not trying to compete with blockchain. We're enablers. So we enable all blockchains, right? So we allow Bitcoin and Ethereum like all work out of the gate, but we also have an open API. Whatever is your blockchain, you can write a small piece of code to make sure the gateway works with you, and it works out of the gate. So we enable everyone, and whoever will do a good job about like capturing this potential and getting a lot of transaction per second will benefit from it, and those who won't, I assume, will vanish with time, but that's how I look at things. So we enable, and it's definitely each blockchain and each crypto ecosystem will decide what to do with this capacity. Our job is to provide this capacity. So
we've got a bunch of embedded parentheticals here, right? So the question before this, you were talking about the win-win-win, and we got sidetracked a little bit. So the users are paying lower fees, the miners make more. Who's the third winner?
BloXroute. Somebody. But let me. So prior to that, so I just want to finish the point of a long-term value and short-term value. Okay.
So this is the third parenthetical.
No, I think it's the second. I think the third was what happened if the protocol doesn't allow for it. So regarding the protocol doesn't, each crypto ecosystem can decide whatever it wants. We're enabling, and whoever will do a good job utilizing this capacity will benefit from it, and whoever won't benefit from it. So we don't take a stand in that. We enable everyone. In terms of who's getting the value out of it, we provide, so what I told you now is the long-term value, and regarding BloXroute, so this win-win-win, BloXroute can't charge anyone directly to use BloXroute. I didn't get to that because we didn't finish the provable neutrality, but we can't because we can't discriminate, right? I can't prevent, like I can't charge you like a subscription if I can prevent you from using me if you're not paying the subscription. So the way we build the incentive is to provide free capacity, right? Up until 100 transactions per second, everything goes. Nobody should pay BloXroute, and there's nothing like that. But we add additional capacity for transactions that pay to BloXroute 5% of a cent, okay, like 10% of whatever the mining fee is. A user, nobody has to pay us, but if somebody pays BloXroute, its total fee would reduce. And why the total fee would reduce? Because when the let's say that the fee usually is a cent. If you're a miner and somebody pays you half a cent, and he pays BloXroute 5% of a cent, you look at the transaction, you're like, oh, he doesn't pay the minimum that I usually require. But on second thought, you know what, this is not instead of the transaction in the free capacity, that 100 transactions. This is in addition to them. So even though it just pays you half a cent, well, you can make another half a cent, and will actually increase the free capacity the more these transactions you include. So you as a miner has an incentive to include this transaction, even though it doesn't pay your regular 1 cent. It only paid you half a cent. So we're providing this fee reduction service. You can pay BloXroute really a minimum, like 5% of a cent. Users shouldn't even consider like their brain about it, but if you want to reduce your fee, you can pay BloXroute this fee reduction service. So this is the win-win-win kind of thing.
Now, it's interesting, but it starts to sound a lot like interchange fees for credit cards. So how do you actually get people to buy into this type of system long term? I'd imagine it's with the token.
No.
So that you're thinking
this,
about long term.
like I'm going to say a word about the token like later, but like we have a security token, which is if you would like to invest in BloXroute. This is not a utility token. It is
for fees, right? So it is a bona fide security, right? You're securitizing
if,
fees.
If you want a piece of these, like 5% of a cent, you can invest in BloXroute if you think this is going to work and it's going to make a lot of money. But it has not. You don't use these tokens at all. So to your question,
Yes.
how do you get people to use this? So I began. There is.
But maybe use is the wrong word, because ultimately I don't think the users care as long as the network is faster and the other kind of critical stakeholders. My question was more about the stakeholder alignment and getting people excited for something like this to exist as infrastructure. If they have a stake in it, which is what the securities token may allow, then it seems like the pushback you might be able to minimize a bit.
So there is something to that, but that's not the route that we're taking. The reason people should get excited about it is, so I talked about the long term. What is the short term value? I go to miners, I go to validators, and I tell them, here is a magic gateway. Now, remember, miners and validators never pay BloXroute. Okay, users can choose. Those making transactions can decide to add an output to BloXroute. This is a free service. We give them to miners and validators. You can hear about blocks 1,000 times faster. Now, if you're a miner, if you hear about a block sooner, you can start mining on top of it sooner, and you can make more money. We have collaborations with with mining pools and large miners and validators and stakers. We tell them, let's try to collaborate. Let's deploy BloXroute, and this is what we're doing right now. If we're successful, we allow them to make more money. So this is a very easy case to go to miners and validators and say, we're trying to help you make more money, because you will hear about blocks faster, and you will be able to make more money. So this is if we talked about long-term value, I want them to make 100x, and I want users to make 10x lower fees. In the short term, I offer them, we scale everything out of the gate. You want 100 transactions per second, free, nobody even pays us for that. You get that now. You never pay us, and if you're a miner or if you're a validator, I allow you to make more money. It seems to be a very like sweet deal to most of them because it seems to be working. Does that kind of make sense?
I can certainly imagine other ecosystems very willing to experiment with this, because out of the box you can think about long-term scalability, and you don't really have the user base or the network to prevent you from taking these types of technical risks or taking on certain design debt as you think about the growth of the ecosystem. What I wonder is, will this ever hit scale for Bitcoin and for Ethereum? Or is this primarily going to be fuel for competitive networks that want to think about raising the block sizes or the states that are stored, and instead relying on a federated group of participants in the ecosystem that are going to store the full state, the full transaction history of an ecosystem, and as long as the connective tissue is fast and reliable and provably neutral, they don't really care.
So here's the thing, you said about the technical debt. Right now, everybody are using their ISP, AT&T or Comcast or whoever. That's a centralized entity. It can throttle you. It already is throttling you. If you're running a node, you're likely actually violating your term, like your service terms and whatnot. And I'm fine with that. I couldn't care less. But if you think that the internet itself, that its infrastructure, that the physical wires everywhere are decentralized, you're wrong. They're not. So we're not really. What we're here is to say, we can actually provide you the same networking infrastructure you're getting from AT&T or Comcast or whoever, but we do 1,000 times faster job doing it, and we're provably neutral in a way that they aren't. And we didn't finish talking about that, but I'm putting that aside for a second.
Well, let's finish that.
Okay,
that is an important point.
The piece that we said about the neutrality was...
We're going to have to clean up these show notes because I'm trying to keep up with you, and I know we've had many parentheticals here. So provably neutral part 2.
So provably neutral part 2. So we said that BloXroute can't discriminate based on the content of the block because that is only revealed after it already gave it to everybody else, right? So block is encrypted, sent to BloXroute to everybody else, and the key is revealed after it was sent, and it's not being sent out until BloXroute had sent it to everybody else. Now, because BloXroute doesn't know how gateways are connected to each other, they keep it hidden. We can't, if you're that gateway, we can't just send it to those you are connected to. We don't know who you are connected to, right? So we have to send it to everyone, or at least to the vast majority, and they will know if somebody, I'm not going to talk about the small details of that, but we don't know the content of the block. Now, to prevent discrimination based on where the block came from, right? Maybe I'm not discriminating based on where it is, but it came from you, and you gave me such a hard interview, I'm not propagating your blocks, right? So gateways do something very similar to Tor. Rather than send it directly to BloXroute, they relay it through another gateway to BloXroute. So BloXroute doesn't know where it came from. So assuming you're a node in North Korea and BloXroute is legally not allowed to send anything to or from North Korea, your gateway encrypts a block, send it through, let's say, a European node. We received a small piece of encrypted data that we don't know where it came from. And the same the receiving end. Your gateway can ask gateways to relay blocks to them. So we don't know where it came from. We don't know where it's going, right? I send it to that European gateway. I don't know that it goes to North Korea. I'm sending it to Europe.
Yep.
So we can't discriminate based on the content of the block. Where is it coming from and where is it going to? Because we don't know these things intentionally. So we can't discriminate based on them. Does that make sense?
Yes.
Cool. So that's on that. There is an additional piece. Okay, BloXroute is fair. But what happens if a meteor comes and hits all of BloXroute servers and now it went down and now Bitcoin went from 3,000 transactions per second to 3, right? We can't have that. We can't be a single point of failure. And to overcome this problem, which is the hardest problem to overcome, we're going to open source our entire code and to allow anybody to deploy a backup network. The idea is you're going to deploy a idle version of BloXroute yourself. So you're going to get the deployment script and everything. And if you have any stake, like you're a small miner, you're a business that uses crypto, and you want to make sure that you receive blocks and send blocks, well, you create a version of BloXroute of yourself. It doesn't do anything. It doesn't incur cost because it doesn't send anything. It's waiting for that doomsday scenario. Okay? If BloXroute goes down,
how many redundant systems would you need?
I think you would like to have like at least in the order of 5. Okay, you need multiple of them. So Coinbase to have one, and via BTC or whoever, or raw pool or any pool out there, like each one of them cares about receiving blocks and about sending blocks, and they want the blockchain to continue. So each one of them paying, I don't know, $25 a year or something like that to have that running, not doing anything. And that's there really never to be used, but it makes sure that there isn't any point in taking BloXroute down because it won't do anything, right? All the magic gateways will do a hot swap, immediately go to these backup networks and use them. Now, if it was a small glitch, well, they will hop back to BloXroute. If it's permanently down, they can continue to use BloXroute for 6 months or a year or 2 years, or until each crypto ecosystem will decide, well, BloXroute is gone. What would you like to replace it with? But that makes sure, and again, this should never happen. This is the doomsday scenario, like I don't know, me or he to everybody, like all our servers or whatnot. But we are
U.S. government just
U.S. government came shut us down. It doesn't matter because everything will continue to operate even if we're gone. We have to be replaceable.
Yep.
But this makes us both provably neutral and not a single point of failure. Does that kind of make sense?
It does.
Okay.
So there's probably another hour that we could cover on this. It's fascinating. It's a much different approach than most of the other scalability challenges and approaches to solving these problems that we hear and read about on a day-to-day basis. What does success look like in the next 6 to 12 months at Layer 0 versus what gets much more press in Lightning and sharding? And,
so if we wanted to do
else.
more press, like we will make more press, or keeping it like in the, like we want people to know what we're doing because we're creating that.
Press should be a function of whether you actually ship. So technically,
we're going to ship at the end of June this year. Okay, so everybody are like I can't stand these like, oh, we're doing this super sophisticated kind of stuff. You don't know if this product is ever going to ship and whatnot. So success for us has several parts. We're doing right now this collaboration with large miners and large pools because we're going for this short-term value that we said earlier. We're deploying it there so we can tell them exactly, okay, without BloXroute you're making X amount of money, and with BloXroute you're making Y amount of money, and how much more money they make. So this is one piece that we're doing. A second piece is actually shipping, and BloXroute is already working. Again, it's already connected today to Bitcoin Core, mainnet and testnet, Bitcoin Cash, mainnet and testnet, Ethereum, several testnets and mainnet. So it's already working out there. Shipping and providing V1 of BloXroute, which has all these bells and whistles. So this encrypting, sending it out, we already have it working, right? Today. We're going to ship at the end of June this year. So that's piece number 2. And going a bit to the business side and the token that you mentioned, our idea is to make receive very, very small payments. Okay, 5% of a cent. Our idea is to give, again, users pay 10 times less fees, miners make 100. We give away 99.9% of the value that we create goes to users and miners. And we capture this 0.1%. But we're very happy with this 0.1% because at 30,000 transactions per second, if you do 5% of a cent times 30,000 transactions per second times 31 million seconds in a year, that's like $460 million per year in revenues with very, very low cost. Our end game is at 200, 300, 400,000 transactions per second, and that's billions of dollars per year. So we're very happy. I don't care. I'm very happy to make to receive very, very tiny payments. And that's our business model. And so we're doing, like, we have a lot of good investors in us. So we have like Coinbase had invested in us, Pantera had invested in us, Finbushi, Metastable, One Confirmation, Zenfund. I can even start Naval had been with us from the beginning. Flybridge, like really, I can start like talking, but it never ends, kind of thing. Another piece of what we do, we allow people to invest in BloXroute. Okay, and the reason that we do that is because if we're receiving money from the crypto ecosystem, it's only fair for it to go back out. It's kind of like, oh, we're receiving all that. We're the bad guy, right? It doesn't matter that we give away 99.9% of the value that we create. If we capture so much value, then we're the bad guys. We're the rent seekers. We're the leechers. So we have to make sure it goes back to the ecosystem.
How much of the revenue stream will a security token securitize?
All these revenues go to the token holders. So if we issue, and we issue a cap 100%. So if we issue 100 and you own one of them, then 1% of the revenues go to you. Now this is even revenues, not profit. So you don't even care how BloXroute works. It's not, oh, what are the costs?
How much are you planning to reserve initially?
So we start. So BloXroute will always be a large stakeholder because this is how, like, this is the revenue stream of the company which has to operate. Our idea is to start by selling 20% out of all of that, and that's like round 1. A year after or 2 years after, when it makes sense, maybe we'll sell another 10% or another 20%. I see BloXroute. I don't want to sign this because like this isn't written in stone. But generally, like, I don't know, BloXroute should continue to hold 50% or something like a. Should it be 40? Should it be 60? I don't know, but a substantial amount of the tokens because this is its revenue stream. This is how it operates. And anybody who's interested in being part of that, and it's kind of, oh, that's a good investment. And again, this token isn't used for anything. This is just if you want to invest in BloXroute and you want a piece of that, small, tiny payments, but a lot of them, then that's a way to go.
Well, technically speaking, I know there's a lot that needs to be proven out still, but it in the lab works. whether what you've developed is ultimately adopted is going to be a function of your ability to close some of the miners, some of these ecosystems, and onboard these new teams. It certainly makes a heck of a lot of sense, at least on the economic side, as you think about enticing people to buy into the system so that they have ownership of the fees long term, and you aren't just extracting rents from the broader ecosystem. So I think that all makes sense.
And on that note, in the lab, it's not really in the lab, it's deployed in the real world, but in order to actually test how much we can do, well, we took the Bitcoin code, specifically Bitcoin Unlimited, because they solved the small bottleneck in the code. We deployed quite a lot of nodes there, and we wanted to see how many transactions per second we can with Bitcoin. Okay, the first blockchain, like you can, it's not like a super sophisticated. We all know how it works. We're seeing peaks at 3,500 transactions per second, like on Friday. That consistently in the thousands. We still have, like, we're now replacing part of our propagation from like into a C++ extension because it's faster, so we can do better. We have where to improve to, but we're already seeing thousands of transactions per second. So this isn't something, oh, it should work. It's working. Like, it's working right now. We haven't shipped because we prefer to actually have the product ready and then sell it rather than the other way around, like happens so many times in crypto. But this isn't like, well, maybe it will work. This works. I know it works, right? It works also for Ethereum. It also scaled that. Not to thousands yet, but it's in the hundreds at the moment. Yeah, just want to point that out.
Well, we're going to know one way or the other in the next few months. Even the skeptics will know one way or the other. So really fascinating stuff. I appreciate you coming on, and this will be up in the next couple of days on iTunes. So our live viewers got a sneak peek. Until next time, we'll have to do it again soon.
That was great.
Once there's once you actually do release in June. But in the meantime, best of luck.
Thank you.
Busy couple of months coming up. So, Uri Larman.
That was fun.
Thanks, guys. Until next time, thank you again to our sponsors at Token Tax and Token Soft. Check them out, and check out BloXroute. Until next time, peace.